two types of non-primitive data structures. First is linear data structure. A data structure is said to be linear if its elements form a sequence or a linear list. A linear data structure traverses the data elements sequentially, in which only one data element can directly be reached. All the data items in linear data structure can be traversed in a single run. Examples of it are array, stack, queues, and linked lists. Let's have the array. Array is a collection of data of similar types. In this diagram, we can see an array of 10 elements with indexes from 0 to 9. So let's say we have this real example as 10 roll numbers of 10 various students. Instead of storing all these roll numbers separately in 10 integer variables, what we do is to create an array of integers and store various roll numbers corresponding to each of the indexes of the array. This will let us save a lot of memories. Next is we have stacks. Stack is a last in, first out data structure where the data added last is removed first. Adding new data element to the stack is called push operation, and removal of data element to the stack is called pop operation. In this diagram, let's take for example a school bus. Suppose there are 5 seats in a school bus. So the very first student riding in a school bus will have to take the last seat, and the second will take the second to the last seat. And just like that, the fifth student will have to take the first seat. Now, when the bus reaches its destination, the student who will be coming out from the bus at the very beginning will be the fifth student, and that is the student who rode the bus at the end. And the first student who rode the bus will be coming out last from the bus. Next is we have queue. Queue is the first in, first out data structure where the data added first is removed first. There are two special terms related to queue data structure. One is back or rear end of the queue, and another is the front end of the queue. Addition of any data element in the queue happens at the back end, and this operation is called enqueue. And removal of any data element from the queue happens at the front end, and the operation is called the queue. Let's take, for example, a queue of students who are waiting for the lunch to be served. So the very first student at the first line of the queue, that is the front end of the queue, will get the lunch first and will be removed first from the queue. And the next student will be inserted into the queue from the rear end of the queue. And this way, the student will get their lunch. Is we have linked list. Linked list is a collection of nodes where each node is made up of data element and a reference to the node in sequence. If we take the same example of storing various roll numbers of various students, we can do this the same thing. Instead of having an array, we can have a linked list. We can sometimes face some memory constraint when we use arrays. So we use a linked list instead. Also, we can store different kinds of data. For linked lists, each of the node have two different fields. One is the data filled with a value, and the other is a pointer to the next node. The first node of the linked list is called head node, and the last node of the linked list has a special characteristics that pointer fill to the last node will point to a null point. The second type of non-primitive data structure is the nonlinear data structure. In nonlinear data structure, every data item is attached to several other data items in a way that is specific for reflecting relationships. The data items are not arranged in a sequential structure. Two examples of nonlinear data structure are graph and tree. First, let's have tree. Tree is a data structure that is made up of a set of linked nodes. It emulates a hierarchical tree structure and forms a parent-child relationship. We can see in the diagram that there are various nodes such as A, B, C, D, E, F, and H. A is called the root node of the tree. B and C are the child nodes of A. D is the child node of B. E and F are the child nodes of C, and H is the child node of D. Now, let's take an example of various employees in an office. All employees have different posts like managers, offices, typists, and clerks. So, if we want to store all this data about the employees and also want to store in a way so that the hierarchy of the post can be indicated properly, we can take this example of tree. So, this node A represents the manager, B and C represents the offices, D, E, and F represents the typist, and H represents the clerk. Next is graph. Graph is a collection of finite number of vertices and edges that connect the vertices. Edges represents its relationship among vertices that stores data elements. In this diagram, we can see 5 different nodes: 0, 1, 2, 3, and 4. Let's take an example and explain how this graph data structure gives us a reflexibility to store the data and define a particular relationship among these data elements. Suppose there are various classrooms in a particular building, and they have this particular relationship that if a teacher takes a class in a particular classroom and there are many other classrooms connected to that particular classroom, then that teacher will have to pick a class in all those connected classrooms. So let us simplify it. Suppose teacher A takes a class in node 0. So as node 1 and 4 are connected with node 0, so teacher A will also take his classes at node 1 and 4. Same if teacher B takes the class on node 1, and as 0, 4, 3, and 2 are connected on node 1, hence teacher B will also take classes at node 0, 4, 3, and